Welcome to the Explainer. So, you're gearing up for a data science interview. You know it's one of the hottest jobs out there, but let's be real, the interviews, they can be intense.
Yeah, it can feel like you've walked into a pop quiz for a class you didn't even know you were taking. You've got all these intimidating, complex-sounding terms flying at you from every direction.
Like, you might get hit with a question about some really complex statistical concept.
Or they'll ask you to break down some advanced technique that honestly sounds like it's straight out of a science fiction movie.
Look, it is totally normal to feel overwhelmed by all this. But here's the thing. There's a secret to navigating these questions with real confidence.
So let's get into it. The key, the big secret, really, is realizing these questions aren't just random trivia. They're actually a map that follows the logical flow of what a data scientist actually does day to day.
And that's exactly what we're going to do today. We are going to follow that map. We'll break down the interview into the same stages as a real-world data science project. This way, you'll have a framework, a mental model, to tackle pretty much any question they throw at you.
All right, first things first. Let's start with the big picture. What is the role they're actually trying to fill? I mean, what are they even looking for? Because understanding this, well, it's the foundation for absolutely everything else. Okay, so at its absolute core, a data scientist's job is to take a whole mess of raw data and turn it into something meaningful, insights that actually help a company make smarter decisions. You can think of them as translators. They bridge the gap between the super technical world of data and the practical world of business. Okay, so keeping that role in mind, let's move on to the first real, practical step of any project, getting the data ready. And let me tell you, this is where a huge chunk of the work happens in the real world. So naturally, interviewers are going to test you on this. They want to know about your understanding of the whole data pre-processing pipeline. The cleaning, the transforming, the structuring, all the stuff you have to do to raw data so a model can even begin to understand it. You've heard the saying, right? Garbage in, garbage out. This whole step is about making sure you're not feeding your model garbage.
So for example, they'll almost certainly ask you how you handle missing data, and you've got a couple of main options. Option 1, just get rid of them. Delete the rows, it's easy, but you lose potentially valuable information. Option 2 is to impute them, which is just a fancy word for filling in the blanks. You can make an educated guess using something simple like the average, or get more sophisticated. But here's the key. The interviewer doesn't care so much about which method you pick, they want to see that you understand the trade-offs.
And it's the exact same logic for outliers. Those really extreme data points that can totally throw off your results. The question you have to ask is this just a typo, a data entry error? Or is this weird value actually telling me something important? Your ability to talk through that decision, whether to just delete it or use a statistical trick to lessen its impact, that's what shows the interviewer you're thinking like a real data scientist.
All right, so once your data is all clean and prepped, now comes the fun part, actually building the model. And as you'd expect, interview questions in this area are all about your toolkit. Do you know what tools you have? And more importantly, do you know when to use each one? One of the most fundamental concepts here is the difference between supervised learning and unsupervised learning. Okay, so with supervised learning, your data is labeled. You already know the right answers for your training data, and you're teaching the model to predict those answers. It really is like giving a student a practice test with the answer key. Unsupervised learning, on the other hand, is more like pure exploration. The data is unlabeled. You're just throwing it at the model and saying, hey, find some interesting patterns or groups in here for me.
Now, you're going to be expected to know about a whole bunch of common algorithms like the ones you see here. But don't panic. Nobody's going to ask you to code a neural network from scratch on a whiteboard. What they do expect is that you can have a conversation about them. Can you explain what a random forest is? What kind of problems is logistic regression good for? What are the basic pros and cons? That's the level they're looking for.
This brings us to one of the absolute biggest traps in model building, and I guarantee you'll get asked about it. Overfitting. This quote just nails it. Overfitting is when your model gets an A+ on the practice test, but then completely bombs the final exam. It's because it didn't learn the underlying concepts, it just memorized the training data, noise, typos, and all. So when it sees new data, it has no idea what to do.
So how do we fight this? How do we stop our model from just memorizing? Well, one of our best weapons is something called regularization. Think of it like this. Regularization adds a penalty for complexity. It essentially tells the model, hey, keep it simple. Don't get bogged down in tiny details. By discouraging that complexity, it forces the model to learn the bigger, more important patterns, which helps it perform way better on new data.
Okay, so you've built your model. Awesome. But is it any good? Building it is only half the battle. You have to be able to prove that it actually works. And that's what this next part is all about, evaluation. Because you definitely can't just say, hey, it's 95% accurate and call it a day. It is way more nuanced than that.
To really dig in and understand how a model is performing, we use this little tool called a confusion matrix. And yeah, the name is a bit funny, but it's an absolute cornerstone of model evaluation. All it does is break down your model's predictions into 4 simple boxes: when you guessed right, when you guessed wrong, and how you were right or wrong. And from that simple matrix, we get some super important metrics, like precision and recall. So precision basically asks, when our model cried wolf, was there actually a wolf? A high precision means your model is trustworthy when it makes a positive prediction. Recall, on the other hand, asks, of all the wolves that were actually out there, how many did we manage to catch? High recall means your model is great at finding what it's looking for. And as you can probably guess, there's usually a trade-off between these two.
You know what else interviewers love to ask about? Ensemble techniques. Fancy name, simple idea. It's basically teamwork for models. 2 of the big ones are bagging and boosting. So, bagging is kind of like asking 100 different people for their opinion on something and then taking the average answer. You get a more stable, reliable result. Boosting is different. It's more like building a team of specialists sequentially. The first model makes a prediction, the second one focuses on what the first one got wrong, the third focuses on what the second one missed, and so on. Each one learns from the mistakes of the last.
And finally, and this is so important, remember that being a data scientist isn't just about locking yourself in a room with code and algorithms. Your ability to actually work with other humans and explain what you found, that's just as critical as the technical stuff.
Because make no mistake, your soft skills are absolutely being tested. They want to know, can you explain your super complex model to a manager who doesn't know Python from a Python? When they give you a vague business problem, how do you even start to tackle it? So be ready for those behavioral questions. They're trying to figure out how you handle challenges, if you're a good teammate, and most importantly, if you can connect your technical work to actual business value. So if there's one thing you take away from all this, let it be this. Stop trying to memorize the answers to 100 different potential questions. It is a losing game. Instead, focus on understanding this workflow, this framework. Think about your answers inside this structure: defining the problem, prepping the data, building a model, checking if it's any good, and then telling the story. If you can do that, you won't just ace the interview. You'll be well on your way to being a really great data scientist.